Hi everyone, in this video I'm going to explain what Nash equilibrium is and how you can find Nash equilibrium in simultaneous move games. So a Nash equilibrium exists if each player's choice of action is their best response to every other player's choice of action. So there is no incentive to unilaterally deviate from the chosen outcome. Now, let's return to our example of a simultaneous move game from the last video. We can go about solving for Nash equilibria by considering what each player's best response will be if the other player chooses a given action. So if player 2 chooses price high, then player 1 can either go price high or low, which will result in either a payoff of 4 or 5. And obviously they would prefer a payoff of 5 to 4. So this is their best response to player 2 choosing price high. Now we'll consider the same thing if player 2 is going price low. They can either get a payoff of 1 or a payoff of 3. And again, they would prefer 3 to 1. And so you can see that in this game, player 1 actually has what's called a dominant strategy for choosing price low, because that will always be their choice regardless of whether player 2 chooses price high or low. Now let's just repeat this process to find player 2's best responses to player 1's actions. So if player 1 has gone price high, then player 2 can either get a payoff of 4 or 5. And they would prefer a payoff of 5. So I'll highlight that. And then again, if player 1 goes price low, they can either get a payoff of 1 for going price high or a payoff of 3 for going price low. And clearly they would prefer a payoff of 3. So we'll mark that. So now that we've considered each player's best responses, the Nash equilibrium in this game will essentially be any box which includes a payoff chosen by both players, which in this game is price low, which is the Nash equilibrium of this game. Now, let's consider a slightly more complicated example where each player has 3 possible actions. Now, these are just arbitrary actions that I've labeled left, center, right, top, middle, bottom. Okay, let's begin. So if player 2 goes left, player 1's best response will be to play middle, getting a payoff of 5. Then if player 2 goes center, player 1 will be indifferent between choosing top or middle, both with a payoff of 6. And if player 2 chooses right, player 1 looks at 7, 4, and 2, and 7 is the biggest. Now let's find player 2's best responses. So if player 1 goes top, player 2 will be indifferent between center and right, both with a payoff of 4. So we'll mark these. Now if player 1 goes middle, player 2 will go right for a payoff of 5. And if player 1 goes bottom, player 2 compares 2, 3, 6. 6 is the largest, and that's what they will choose, right? So we can see in this game we've actually ended up with 2 Nash equilibria at top center and top right, which is entirely possible in these games that there can be 2 Nash equilibrium. So that's it for this video. I hope you've found it helpful, and please feel free to leave any feedback or queries in the comments section, and thanks for watching.